Welcome back, students. Science 24, Unit B. This is Lesson 3, and we're going to do some energy conversion calculations. All right. We're going to calculate efficiency, and we're going to do two different types of calculations. So remember that we have energy conversion in an automobile. So gasoline we put into our gas tank, and then we pump that gasoline into the engine so it gets into here, and then we burn it. We light it on fire, basically, which is chemical energy. There's chemicals, there's energy inside the chemicals. And then we convert that into mechanical energy, parts moving up and down, pistons moving up and down, wheels turning. We get heat, we get electricity, we get light. So there's lots of different conversions happening in an automobile. Chemical energy is being converted into light and electricity and heat and mechanical energy, motion. Remember, we can't create energy, we can't destroy it, but we can convert it from one form into another, which is what you see there. And remember, the energy, we can't create it, we can't destroy it, so it's equal. The amount of energy we have here is equal to the amount we have here. Now like I said in the other lesson, I'm not showing that we're losing energy anywhere. We actually are, but it still gets added into the total. And so what this teeter-totter is meant to show is that you're not creating energy, you're not destroying it, you're just converting it. Okay? Now we can do some calculations. We have input energy. So I might have energy that I put into the system, and then it gets converted to the energy that comes out of the system. So I fill my car with gasoline. What do I get out of that? Well, I get output energy. I get some light. I get some electricity. I get some heat, and I get some moving parts. Okay, so I have input energy and I have output energy. Okay, and because of that, we can do some calculations. Some of the energy is useful and some isn't. So the fire that is inside the engine when the gasoline burns, there's fire in there. Like there's a spark in there, but I don't even see that light. So some of that light is not useful to me. The light energy that comes out of my headlights, that is useful. Some of the electricity is useful. Some of it isn't. I lose some, I get some friction in there. Heat energy, some of that is useful, some of that isn't. So mechanical energy, the wheels move and all that, but there's friction and I do have heat loss. And so some forms of this energy are useful and some are not. Okay, let's jump to the calculation. Okay, so here's what we're going to do. The first type of calculation is calculate how much useful energy is provided when I'm given a percent. So let's read the question. A car that is 85% efficient consumes 9,200 kilojoules of energy. How much energy does it consume? In other words, how much useful energy does it actually have? Because I have 9,200 kilojoules, but it's only 85% efficient. Okay? All right, so how do I do this? Well, I take this number, 9,200 kilojoules, and then I just times it by this number. And whenever you do that, just take that number and put the decimal in front of the number, 0.85. And that equals 7,820 kilojoules. Okay? So take that number, put a decimal in front, and you'll get your answer. And put a box around your answer, 7,820 kilojoules. Which means I have 9,200 kilojoules of energy available, but this machine only works up to 85% efficient, which means I really only get out 7,820 kilojoules. Okay, so I can show you that again this way. So I start with 9,200 times it by that number with a decimal in front, and I get my answer of 7,820 kilojoules. Okay, that's calculation 1. Let's do calculation number 2. Okay, type 2. Now we're going to calculate percent efficiency when I'm given the input and the output. So a car consumes 9,200 kilojoules. That's the input. In order to provide 7,820. That's the output. I start with 92, I end up with 7,820. What's its percent efficiency? Okay, so here's how you do it. I take useful energy divided by total energy times it by 100. All right, so what's useful energy? That's my output energy. So 7,820 is useful divided by total 9,200 times by 100 equals 85. Okay? Another way to think of it is you're always going to take the smaller number divided by the bigger number and then times it by 100. This gives you a percent. Okay? All right, so useful energy, or the output energy, or the smaller number divided by the bigger number times by 100 gets you your percent. Okay? All right, there's some questions to do on that, boys and girls. Thanks for watching.